What we're going to do in this session is take one of the objects in a model and follow it all the way through into the code of the application. For this, we're going to use the employee object that's in this model. This is a central component that allows a user to be set up based on the employee of a company. This employee can be a manager, can have a manager, and then it has references to a bunch of the other objects. So we're going to go ahead and follow this through. The employee, as far as this object representing the actual person that logs into the system and has access to their information, and then they have orders that they can put in, stuff like that. So it's a password protected system and stuff. So for the model itself, what can be generated is we looked at this before, all the different areas of generation that gets done. Now what we're going to do is actually look into the source code that gets generated. And this is all 100% generated. We never really directly touch it or even have to, just again because the model is rich enough to let us put all the information in there. So from the model, the class that gets generated is called, I'll start from the top, is employee. It extends this base OA object, which is the main base object for the DAO type objects within OA that are used for all the model objects itself. And from here, just a brief description is it will create some static references to all the names of the properties and stuff, so that when we do binding, we can bind directly to the actual property. Whenever we build what's called these property paths, we can use these also, and that allows the compiler the catches from any typos and stuff. And then the actual properties themselves are stored here, from the ID to all this information, and then reference information. One of the things about the object when it's in use in a live application, this information isn't all just loaded up with employee. This information is, because that's comes straight from the record in the table. This information, foreign keys are loaded directly, again because that comes with the record when it loads up the object. References to minis and stuff like that are basically set up to be fetched on demand, or it could be set up so we can tell it to go ahead and prefetch some stuff along with it. But by default, it pretty much does it when it's needed. The object itself has a constructor. The OA object has some built-in functionality that's useful, again, on how these objects work together and how they interact in a observable manner. So we know if it's being loaded or not, stuff like that. So the constructors here, the ID itself is a property, and the ID in this case, in most cases, is going to be the ID of the object, which is going to represent a actual ID identifier, which is once it's assigned is not changed again. It's treated as a primary key. And so there's annotations that go with these properties, again, that come straight from the model. And it's basically all the way through. OA object will make sure that, again, the base class will make sure that this object being unique and being the object ID is not able to be changed. It allows for some internal hashing on it and stuff like that. Equals operator caching is also set up for that. So if we go through all the properties, and what we're going to do is skip on down to some of the references. So before we get to that, we'll talk about the calculations. So here's a calculated property that basically is called first last name. So for first last name, we want to be able to go get the first and last name. The code for that, again, is in the model, and it's put into the delegate just to kind of keep things organized and kind of clean. It basically takes the first name and last name, concatenates them together, and then returns the value of that to be the full name. The other thing that it has built into the annotation, and again we spoke on this as far as calculate properties when we were discussing the model, is what properties are needed to make up this calculation. So what are the dependent properties? And those are all in here. So if our application is using first name, if we have a component that's visually displaying it and that needs to be updated whenever it gets changed, it will automatically create a listener on this, and we'll see that in a little bit. And based on that this property being listened to, the code that does the listening and built into how OA does this observable patterns and what's some of the functionality built into that, is it will automatically get this dependent properties for us and listen for that. That's there's some features for the observability that's built into it that uses reflection and metadata type information through annotations and stuff that allow it to be able to do this automation for us. So we have a list of all the calculate properties, again with their dependent properties, all defined here. The actual code that gets called when this happens. If something changes, event goes out, just like any other property gets changed. And then the next area of properties we get to is reference properties. So there's ones or minis, and obviously there could be there's the other side of this, the other object that it forms a relationship to, and that could be a one or mini on its side. So it forms combinations of those. Within these relationships, it has the one or many. If it's a mini, it will return a collection of these objects, and the collection class in OA is called a hub. And a hub being a collection similar to, it's basically an observable array list with some additional functionality as far as the collection itself is concerned. The annotations also further describe any information cascading. Again, this all comes from the model. The OA components that are used here, the base classes, the hub and stuff uses that information. The UI uses that information, again, to know how the whole thing works together. The other thing to notice here is an employee has, in this case, a hub, a collection of employee awards. So the code to actually go get those awards is basically right here. This basically is saying if the employee awards hub is not been created, then it goes to the OA object to go get those. So what OA object has built into it is it knows enough information about, it knows that this is employee, it knows it wants it wants to get the reference for the employee awards, it knows some metadata about this. It will then query the data source to get this information. It basically says, give me the collection of employee awards for this employee, which will go to the data source. The data source then will figure out the registered data sources that handle retrieving or working with the employee award class, and what it will do is build the query saying select all the employee awards where employee ID equals whatever the instance of this employee is. So that's, and just say its ID is 5. So we'll build that query. It will go to SQL, convert that to take that, convert it to SQL, go to the database, this being a JDBC, generate it, bring back the object, populate that employee award objects into the collection by adding those to the collection class, and return that. Now that it's returned, this collection knows where it came from. The hub collection has the concept of the master object, like a master detail. So it has that relationship between those. And there's some stuff that some automation and some features that that gives us by having that in place. So that's a mini relationship, bringing back a collection, and we can see a few of these. Here's a one relationship. One basically says this employee has a type, an employee type. So this is their manager, supervisor, vice president, something, or however those could be set up. So what this will do is very similar to the get the collection. It will say, give me the object. Again, it goes into OA object, the base class for this class, and it will do the same thing to get the employee type. The other thing that it's able to do is it knows the type because it also has a reference to it, a key. Again, a database key is going to be like the ID of it. So maybe this employee type's a 7. So there's a caching going on behind the scenes, and it's cached based on how it can figure out lookups on the ID. So in this case, the foreign key will give me the ID, so it can look in the cache to see if it already has that object loaded and use it, so it doesn't have to go through any database query and stuff like that. If it's not loaded, basically then goes through the very same type of mechanism that we talked about to get the collection. For the references, there's a getter and a setter. For the hubs themselves, for a mini, there's just a getter. Basically, once you get the collection, you could add, remove to that collection. For an employee, you can set its type, so you can get the type and set the type. Okay, since this is observable for anything, all the set methods, there's a fire property change. Fire property change basically is saying a property within this class or within this object has changed. Here's the old value, here's the new value, and OAObject then has a method that will handle this. And again, this is part of the observable behavior. OAObject, what it will do is it will send this event out. And the next question is, well, who gets the event and how do you set up the code for this for these listeners of events to actually get them? If every piece of code that had to listen to any change to any object would have to register itself to get these events, there would be a lot of overhead. So instead, there is a way that event listeners are handled at a collection level, and we'll be discussing that level, or that level of connectivity, I guess, later. Here's some more minis, and I believe this is going to take us almost to the end. At the very end of the class, there's custom methods get put in here that we put in, and then there's a load method. Okay, a couple ways that the class can be generated. One is it could be loaded with no reference to any DAO type ORM, database relationship type stuff, and that could all be put into this the default mechanism that uses the reflection classes to do that, or the code generation can generate a method that will automatically load based on a result set. And there's some reasons why we want to do that for efficiency and performance and stuff like that. So all this is able to get generated from the code generator, since we know it's a SQL database dealing with result sets and stuff like that, is this will automatically load the object up. OAObject base class automatically keeps track of if an object's been changed and also if it's a new or not, so we can set those flags after it's been loaded. And this is the data object for employee. The next object I was going to look at is the actual ORM portion of it, the data source. And something about data sources before we look at this is these applications aren't dependent on using a certain ORM or a certain way of doing it. It could be manually loaded. You could write the code to do that. You could use a Hibernate. You could use Ibatis. You can use, I've used TopLink in another project before. It's just that it does come with one, and it serves its purpose and handles everything else, that we need to be able to do. So it's worked out well. It ends up being a single class that does all this mapping, and it's more of a natural fit for working with the objects and stuff. If we look up employee, and then columns. Here's the mapping for employee. It will basically map out the properties to the columns and stuff like that, give some additional information, and then it will also map out some additional information about the database indexes and stuff like that. So with this information, along with the type of database, which has its own information about that called metadata, this information about it, and the information about the classes and stuff, when the application starts up, when it loads up this data source, which again is mapping everything together, and it's critical that they stay in sync, so there's a validation that can be done. And we talked earlier about there's a data source controller which handles the data source and loading it up and everything, and part of its job, or part of it, the functionality of what it handles, is it will go ahead and validate that the object and the relational side of things are matching and everything, and that no indexes are missing, and stuff like that. So this object basically this data source object is pretty large. It's all 100% generated by the tool, and it's just kind of boilerplate type generation. Then it will create these DAO, data access objects, built into this, and this will automatically call the object out, to load itself with the result set and stuff like that. So again, this is something that's automatically generated, and we get for free whenever we do queries on the objects and stuff like this. Based on the object class, it will find the data source, again JDBC data source. That data source will use this information to be able to query from the data source, load up the objects, and return back a collection of objects. So it kind of automates the whole process of loading them up and stuff. As far as transaction management and stuff like that, OA also has built into it, so you can start a transaction, commit it, roll it back, and stuff like that, and it will automatically handle that within this. The other thing is sometimes you want to directly get to a connection or a connection pool or a statement and stuff like that. So you're able to get to anything JDBC related because again, this is using JDBC. You can basically get the JDBC data source, and then it has all the methods to get directly into the JDBC side of it. So there's nothing that's totally hidden. It's just automated, and then in any case where you need to directly get to it, you can. I'm going to stop this as far as from the employee side, and then we're going to continue about how the model gets done and the UI, and then that'll be able to finish this off.